look at the third way of naming compounds. This is the way we name compounds if we've identified that first element in the formula as a transition metal. Okay, and that's that set of 30 metals in the center of your periodic table, your D block elements or your D block metals. It also includes tin, Sn, antimony, Sb, lead, Pb, bismuth, Bi, and polonium, Po. You'll kind of see those over on the very lower right part of your metals, right under the stair step there, starting in groups 4 and 5. You see them over there. You'll kind of see them over there. So look for those. Those 5 plus any of those 30 transition metals, we've got to have a kind of a different way of naming them so we know what's going on. Now, here's the good news. It's like naming a group 1, 2, or 3 metal and an anion, in that we're going to give the metal its name, we're going to give the anion its name. Our exception is that we have to tell each other what the charge on the metal cation is, because these metals form more than one cation. For example, rhodium, I think it's element number 45 on the periodic table. It can form a cation with a 2+ charge, a cation with a 3+ charge, or a cation with a 4+ charge. So we have to tell each other which metal cation we're looking at. So if we had a rhodium compound, we would have to name it rhodium 2 or rhodium 3 or rhodium 4, and then whatever the anion's name was. We're going to use a Roman numeral to designate the 2, the 3, or the 4, or whatever charge is on our metal. Now, here's where we've got to do a little work. We have to calculate the metal cation charge. And the way we're going to do that is we're going to start with something we know, which will be we'll know the charge on the anion. And therefore we can kind of back calculate to what the charge on the metal has to be. All right, so we're going to look at a little example and walk through it here. I have the example Ni2SO4 taken 3 times. All right, now from this, when I see nickel, I find it in the periodic table and it's right there in the transition metals. So I know I'm going to name the metal. I'm going to put a set of parentheses behind the metal name, in which I'm going to put a Roman numeral to tell me what the charge on the nickel is, and I'm going to write SO4's name, which is sulfate. All right. Now we've got to calculate what goes in that set of parentheses, what charge the nickel atom has. We begin by looking at the anion. So if you look at your anion sheet and find sulfate, you'll find it has a 2- charge. That means every sulfate in that formula is carrying a 2- charge with it. All right. Now we're going to do a little multiplication to find the total anion charge. And that total charge is the charge on the anion itself, which is a -2 or 2-. And how many anions are in there? If you look at your formula, you see 3. So what you see is I've taken a -2 times 3, and I get a -6. So that says that all of the SO4s here, those 3 of them, contribute a -6 charge to this compound. Now this compound has to be neutral. So if I've got a -6 from the anions, I have to have a total of a 6+ from my cations. All of my cations in there their positive charges have to be exactly equal to all the negative charges from the anions. So I have to have a +6 there. All right. So that means the charge on each nickel atom, I have to do a little division. We've got to take the total cation charge plus 6. I've got to divide by the number of nickel atoms in there. There are 2 nickel atoms. 6 divided by 2 is a 3+. So I'm going to come up and put a Roman numeral 3 in those parentheses and correctly name my compound. Nickel 3 sulfate. All right, so let's kind of walk through those steps again. I'm going to identify the first element. If it's a metal, I'm going to look for, is it a group 1, 2, or 3 metal? If it's not, I know it's a transition metal or one of those other 5. So I'm going to have to name the metal. I'm going to have to name the anion, and I'm going to have to put the charge on each metal atom in parentheses there. I have to back calculate that charge. I start by knowing my anion and what its charge is. I multiply it by the total number of anions shown in the formula to get the total negative charge. The cation total charge has to be just the opposite of that with a plus sign. And then I have to take the total charge and divide it by the number of metal atoms in the formula to find the charge on each metal atom. Okay? Time for practice. Here are 6 compounds for you to practice. Fe2O3, NiBr3, CO, that's a capital C and a little o, CO, OH taken twice, SO3, PbO2, and Bi3, PO4 taken 5 times. Like we've done in the past, I want you to put this on pause. Want you to go through those steps, practice naming these, and then when you think you have the right name, I want you to restart this and pull up the next slide to look at what the correct names are, and then we'll kind of walk through them. All right? Put it on pause, work it out, pull it back up to find out what the right answers are. Okay, here are the correct answers. Fe2O3 is correctly named as iron 3 oxide. NiBr3 is correctly named as nickel 3 bromide. CO, OH twice, is correctly named as cobalt 2 hydroxide. AuSO3 is correctly named as gold 2 sulfite. PbO2, this may have stumped some of you, is correctly named as lead 4 oxide. And then the graduation exercise here, Bi3, PO4 taken 5 times, would be correctly named as bismuth 5 phosphate. If you got all those right, congratulations. You are ready to go to the worksheet and work through those examples you've got there and get those right, and you'll be ready for anything on the test or the quiz. All right, if you experienced some problems, let's talk about the way I would go about doing this. So let's take the Fe2O3. All right, we're going to say that Fe2O3 kind of has the cation here and the anion here. So I know, first thing I'd write is iron something oxide because I identify iron as a transition metal. All right, oxide on your anion sheet is an O2 minus, but there are 3 of them, so I have 6 minuses back here, which means I've got to have 6 pluses up front to counter that. But how many irons are there? 2 of them. All right. A plus 6 divided by 2 is a plus 3. So that is what I brought down and put in there. All right. Let's look at nickel NiBr3. Again, I'm going to say, well, it kind of forms a cation and anion right there. Nickel's my cation. It's a group. It's a transition metal, so I'm going to name it. I'm going to name the anion attached to it, bromide. And then I'm going to calculate the charge. If you look for bromide on your sheet, it's Br with a minus, right? There are 3 of them, so I got 3 minuses from the anions, so I have to have 3 pluses from the cations. There's only 1 nickel in there. A plus 3 divided by 1 is equal to a plus 3. It's a plus 3, and that's what went in there. All right? Parentheses are nice because they show us exactly where we're going to break this thing apart. All right, CO, not C, capital C and capital O, but C and lowercase o. So that's cobalt. That's a transition metal. OH on your anion sheet is hydroxide, and I think it's written as OH, and it's got a minus sign on it. So that means each OH has a minus sign on it. There are 2 of them, so I have a minus 2 from the anions. So I've got to have a plus 2 from the cations. There's only 1 cobalt in there. Plus 2 divided by 1 is still plus 2. So that's how I found out that that's what Roman numeral 2 was in there. All right. Au breaks apart right there, right? Cation, anion. Au is gold. SO3 is 1 anion. Remember, if it's 1 anion, we usually don't write it in parentheses. So what I'm looking at is SO3, and that has a 2 minus on it. and there's only one of them. Okay, I know that confuses some of us. Some of us see that 3 and say, oh, there are 3 of them, so I get a -6 here. Nope. You have one SO3 polyatomic anion, one sulfite anion. So you've got only a -2 charge back here, so you only have a +2 on the cation side, and again, one gold atom to do that tells me that that's a +2. So that's how I got gold 2 sulfite. All right, this is the one that gives us some trouble. So we're going to kind of break that apart there. Now, lead is one of those 5 that I said we have to treat like a transition metal. All right, so I see it, so I'm going to say it's lead something oxide, right? Oxide was a 2-. I have 2 of them in there, so I have a -4 back here. So from the cations, I need a +4. But I have 1 lead to do that, so 4 divided by 1 is equal to a +4. And that's how I got the Roman numeral 4 in there. Lead 4 oxide. All right, now this one should be, I think, if you've been able to do those, this one ought to be fairly easy. Again, metal and anion divide right there. Bismuth is one of those 5 that needs to be treated like a transition metal. So I write bismuth. I find PO4 there. I know that's phosphate. I write it down. Now if you look on your anion sheet, PO4 has a 3- on it. So 5 of those are in this compound. 5 PO4. So that's like a -15 back here. So that means what from the cations? Yep, a +15. But I have 3 bismuths to do that. 15 divided by 3 is a +5. And so that 5 is the Roman numeral I put in there. Bismuth 5 phosphate. I hope that this has given you some good guidance on how to go about doing that. I would not suggest trying to shortcut too much. Go through your calculations. Make sure you've calculated right. If some of you don't remember your Roman numerals up through about 5 or 6, you might want to relook those. But in any event, you've got the basics for naming transition metals and anions. And on your worksheet for this lesson, you've got 8 to 10 of those to do. So go ahead and get those done, and then we'll do a short series of videos on going the other way. When I give you the name, you put it together to come up with the right formula. So that's going to end this video.